Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. This topic is about system model representation. Okay, this one is under chapter 3. Okay, so kita dah masuk chapter 3. Okay, what topic in this chapter? Okay, so there are 4 subtopic. Okay, first transfer function. Okay, transfer function basically already discussed in chapter 2. Okay, so the idea we already known. Okay, and then steady state representation. Why we introduce to you steady state representation. Okay, because sometimes the system is too complex, which is we have more input, more output. Okay, this one is the basically the example of steady state. Okay, Q dot. Okay, and then block reduction. Okay, this one is a block reduction. Okay, block reduction. Okay, so you can see here. Okay, so there are 3 block diagram combination. So it's so difficult to find transfer function. So that's why we need to reduce block diagram. A few block diagram here. Okay, so what happen if you what's it? G1, G2, G3, maybe G3 here. Okay, so you send to find, okay, what happened. So we want to simplify the block diagram, okay, to find the transfer function. Okay, and then signal flow diagram. Okay, this one. Okay, this is a simple signal flow diagram. Okay, so basically signal flow diagram also to find the transfer function by using Mason rule. Okay, this one is a cost outcome. Basically, the cost outcome is same as the previous chapter, chapter 1, chapter 2. Okay, in this in this chapter, we also can find transfer function and steady state using steady state. And then also you can type word transfer function to find transfer function itself. Okay, using MATLAB. Okay, this objective of this chapter. Okay, basically one by one chapter objectives by topic. Okay. Okay, so already I mentioned what do we learn in this chapter. Okay. Okay, we go through the first topic. Okay, this one is a transfer function. Basically, for transfer function is to describe the relationship between input and output for linear. Okay, for linear. Time invariant. Okay, time invariant. Okay, linear, time invariant differential equation system. Okay, this one is term. Okay, so you can find in Ogata or NICE. Okay, to find detail what is a linear, what is a time invariant. Okay, differential equation. Okay, basically you know lah, kan? Okay. Okay, next we go this one. Okay, the meaning of transfer function. Okay, so we want to know what is the transfer function. Actually, what is the definition. Okay, the definition of transfer function is defined as the ratio of the Laplace transform of the output respond to the Laplace transform of the input driving function under the assumption that all conditions are zero. Okay, so there are three item. Okay, 3 benda yang kena consider dalam transfer function. Okay, first is output. Okay, and then second one is an input, and then next is a initial condition are zero. So this one is the equation. Okay, for transfer function. Okay, output divided by input. Okay, so you can write in terms of this one, in terms of polynomial equation. Okay, this one is applicability of the concept of transfer function. Okay, so you can see here there are 5 concepts. Okay, first is a mathematical model. Okay, basically in the previous chapter, in chapter 2, we define mathematical model to find the transfer function. Okay, so you know what is the input, what is the output. Okay, for the mathematical model. Okay, and then number 2 is a property of a system itself. Okay, so you can see what is output and output, and you know that what is the property in the system. Okay, for example, electromechanical, the output divided by input. Output is a angular speed, but for the input is a voltage. So kat situ tahulah apa itu property for electromechanical system. Okay, and then transfer function include the unit necessary to relate the input to the output. Okay, so unit basically unit for the transfer function is depend on the input and output. Okay, for example, electromechanical angular speed divided by voltage. Okay, so itulah dia punya unit dia. Okay, so depend. Ada sistem yang unitless, ada yang ada unit. Okay, tapi biasanya ada unit lah. Okay, and then number 4, if the transfer function of the is known, the output of a response can be studied. Okay, based on the input. Okay, but if the transfer function is unknown, it may be established experimentally by introducing known input and studying the output. Okay, but for this one, the transfer function is unknown. So you can introduce the input and then barulah you can study the output based on input. Okay. Okay, this one is a summary for chapter for the transfer function. Okay, so there are 5. Okay, 5 concepts. Okay, you can read previous slide. Okay. Okay, next is about convolution integral. Okay, this one you can find in Ogata textbook. Okay, you can find in Dove textbook. Okay, it's a more explanation about convolution. Okay, so you know that G equal Y divided by X. Okay, here. Okay, this one is a transfer function. Okay, and then you must assume that all initial conditions are 0. Okay, and then you can write ys equal g multiply x. Okay, so here. Okay, so meaning that you can find the y. Okay, you can find the output. Okay, based on g. You tahu. Okay, this one is a known. Okay, this one is a known. Okay, so you can find the output. Okay, and then but if you multiply happen, okay, for example here, okay, x tau multiply g tau, so meaning that there are two component now, okay, two system in this mathematical. Okay, so this one, so maksudnya this one is a transfer function, this one is the input. Okay, so you just multiply this one, okay, you can get the output. Okay, if x tau and g tau equal 0, okay, but in within time less than 0, so meaning that y equal 0. Okay, sebab this one 0 dah 0, so but you kena tahulah t ni less than 0. Okay, this one we call as a convolution. Okay, so nanti kita tengok lagi detail pasal convolution. Okay, and then next we go to the impulse response function. Okay, so consider the output of a linear time invariant system to a unit impulse input when the initial condition are 0. So sekarang dia punya input adalah unit impulse. Okay, so unit impulse is unity. So input so x equal 1. So that's why you akan dapat y equal gs because x equal 1. Okay. So from this equation you can find the inverse. Okay, so inverse and then you inverse for gs. So gs equal gt. Okay, for gt, okay, so gt we call as the weighting function of the system. Okay. Okay, next kita tengok lebih detail on the convolution system. Okay, so convolution system ut equal 0 when t less than 0. Okay, so maksudnya kalau ut 0, so output dia pun akan jadi 0. So the idea dia adalah this one. Okay, equation this. Okay, sama macam saya punya slide. Okay. Okay, property for convolution. Okay, so you can see there ada 4 convolution. 4 property of convolution. Okay, first is convolution is convolution systems are linear. Okay. So maksudnya dia berkadar langsung. Okay, linear property. Okay. Second one, convolution system are causal. Okay. So meaning that the output at time t depend on the past input. So that's why kalau ut equals 0, so meaning that yt equals 0 for t less than 0. Okay, and then number 3, convolution system are time invariant. Okay, so if we shift the input signal u over capital T greater than 0, so you apply this one. Okay. So basically on logical lah kalau kita kata t less than 0. Mana ada t less than 0 kan. Macam itulah. So that's why ut equals 0. But t greater than 0, we have a function. Okay. Okay, so you tengok kat sini. Okay, same. Okay, this one ut equals 0 dengan ut this one. Okay, so you just see the output. Okay, yt equals 0 because t equals 0, ut equals 0, and then yt equals y bracket t minus capital T. Okay, and then last one is a composition. Okay, this one is a property for convolution. Composition of convolution system correspond to multiplication of transfer function and then convolution of impulse transform, impulse response. Okay, I think that's all for transfer function. Okay, so you can read more and more. Okay, but the idea for transfer function is just to know what is a transfer function itself. Okay, transfer function is the ratio of output, Laplace transform of output divided by transfer Laplace transform of input with initial condition are 0. Okay, that's all for topic 1. Okay, thank you.